All right. Happy Thursday, everybody. We're back on Advent of Code. We missed yesterday because I went to a bar trivia night the night before, and then I was like a little bit tired yesterday, and I'm like, I'm a little baby. I'm a little baby, and I can't get on camera when I drank a little bit last night. So we have to do day 3 and 4 today. That's the plan. And as far as I remember, the story is we are these little elves, or we are maybe a single elf, maybe, and we are trying to go to the North Pole. So it looks like we're slowly unlocking like this map, this ASCII map of the North Pole underground base. Day 1, we had to like open the door, so we had to like enter a password into this thing. We wrote a program to figure out the password. Day 2, some little child messed up our database, and so we had to go and find all of the invalid IDs in the database and fix them for our friend. And so we were kind of like walking through the gift shop on the way out. And so today I assume that we're getting farther into the factory. I assume. Lobby. We descend a short staircase, enter the surprisingly vast lobby, and are quickly cleared by the security checkpoint. When we get to the main elevator, however, we discover that each one has a red light above it. Each of the elevators, they're all offline. Okay, sorry about that. Enough apologizes. He tinkers with the nearby control panel. Some of the electrical surge seems to have fried them. I'll try to get them online soon. You explain your need to get further underground. Well, you could at least take the escalator down to the printing department. Not that you get much further than that without the elevators working. That is, if the escalator weren't also offline. So maybe we're fixing the escalator? But don't worry, it's not fried, it just needs power. Maybe you can get it running while I keep working on the elevators. Perfect. Perfect. There are batteries nearby that supply emergency power to the escalator for such an occasion. The batteries are labeled with their joltage rating. Why? This is a link to 2020 day 10. That's crazy. They have lore. They have lore. Value from 1 to 9. You make a note of their joltage ratings. For example, this. The batteries are arranged into banks, each with a line of digits in your input. Okay. So there's a grid of batteries. This is a lot of fucking batteries. Okay. Within each bank, you need to turn on exactly 2 crazy. Okay. The joltage the bank produces is equal to the number formed by the digits on the batteries you turned on. For example, if you have a bank like 1, 2, 3, 4, 5, and you turn on 2 and 4, it'll produce 24 jolts. That's crazy. That's an insane. Wow. I want stuff like this that works in real life. That's crazy. You'll need to find the largest possible joltage each bank can produce. Oh, sure. So we pick 98, we pick 89, we pick 78. Right, so you're like basically looking for the largest 2 digits. Yeah, you're literally just like, what's like the ON solution here? You have to look at each digit at least once, probably. I don't think you can avoid that. And you're just looking for the 2 biggest digits and then printing them in order. Yeah, something like that. The total output joltage is the sum of the maximum joltage from each bank. Sure. So we assume that there's going to be a harder part 2, probably where you can rearrange the batteries would be my guess. But let's get moving. Let's get moving. Start day 3, part 1. Okay. I guess day 3. And in here, I guess we probably want to be in a shell that has Zig, huh? Probably want to write some code in a programming language, if you think about it. Bum, 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 bum. Okay, give him a sec. He's thinking. He's thinking hard, this guy. Okay. Day 3. So what is it? We have lines of stuff. We read them from a file. Const stud is equal to import stud. Open file. We'll call it day 3 input text. And we are going to say we're going to need a reader for this thing. So let's get like a little buffer for this thing. And do, reader is f reader backed by this buffer. Beautiful. I think I like saying joltage. Yeah, I do like saying joltage as well. Then we are doing something. While reader interface take delimiter exclusive. And then was somebody saying that I don't have to do like end of stream checks somewhere? Because I've been doing this. Const row is this, and then like I've been catching and looking for end of stream. But I think somebody was saying that there's some way to do it where it will automatically return null if I hit the end of the file, which would be maybe nicer. Which would maybe be nicer. But it's okay. You've just been using take delimiter and never check. But doesn't he error out? If end of stream, he just returns remaining. Oh, so you can check if the length is 0, probably, right? Oh no, he returns error end of stream here. I guess I will keep doing this. Okay, so each row has a bunch of numbers, and we're literally just printing the largest two, right? Max's is going to be 2 U8s, I guess. Like this. And I guess we just go like for character in row. And we do like can we do this without having to check both maxes every time? I mean, it doesn't really matter, but I'm kind of curious if there's a way to do that. I guess it's like if C is greater than max is 0. I guess what you can do is you can like double buffer this thing. Can you do that? Like you could do something where you're always comparing with the lower. Yeah. So we want to make it so that like max's 0 is less than or equal to max's 1 all the time. So let's just kind of like assert that here. And then we can kind of like just make sure that that's always true. So here we're looking at max is 0. If we are bigger than that, oh, we have to keep them in order though, right? We do have to keep them in order. So maybe we should make it so that hold on, how does this work again? We do have to stay in order of here as well. Do you have to rip the list twice? Yeah, because you can't, it's actually not just the 2 biggest, right? It's like, you want the biggest one in the first digit. And then the second, like the biggest after that afterwards. So if you iterate forwards, is there some trick where you, versus like if you iterate forwards versus backwards, to do this in one pass? I guess you always need at least 2 digits. You need at least 2 digits all the time, right? So the first loop, you're probably iterating for like this, like -1 on the length here for this is the first character. And then every time you get larger on the first character, you reset the second one, probably. Yeah. So it's like, if this is greater than max's 0, then max's 1 is equal to 0, probably, right? Because you can only, yeah. And then if C is greater, maybe you do like some sort of index thing. Hold on. Var I equals 0. I want to try doing something like where you go while I out here is less than row len. I feel like you can do something tricky here where you I haven't quite figured this out yet. But it's like if you increment if you increment the first one, then I feel like there's something where you can go like I plus equals 1 here, and then keep going for character 2. I don't really know why I think that, or if that's even makes sense, but it's how it feels. Yeah, okay. Boom, boom, boom. Right, so look at these characters. This one is like, oh, I'm bigger, or something. This is like 9. Then I feel like we are only looking at the next character, but we don't really know that. I guess every character going forwards, if this is like 8, every character going forwards could be a 9. So what we should do, we always have to compare with the first character. I think that there's not really a way around that. I think. So that's this. Then what? And I don't think this assertion is true anymore. I guess we could always compare with the next character. Does that make sense? Do I want to be doing that? So there's 2 options here. If I do this, where I compare the character like C with Max's 1 as well, then it feels like if both of these trigger, then there's like a problem. That's kind of what I've been having in my head here, where like you don't want to trigger both of these at once. So I guess it's this. I guess this is probably correct. Yeah, in which case yeah, something like this. So then we look at the second character, and Max's 1 is equal to C or something. That seems reasonable. And then are we kind of covering every character? We're probably not, right? So we need to kind of cover like the last character at the end. You know? Yeah. Yeah, I don't know. Something like that. I think that makes the most sense to me right now. Jakey Theus, thank you for the tier 1. Much appreciated. I think that's fine. And then here we just do print the maxes for each row. Let's do this for now. Sure. And then we need our input. Something like that. Where is my puzzle input? Here. Holy. Alright. Cannot assign to constant. So true. Okay. So this is a pain in the ass. Can we do it on the example first? And then we probably want to write some tests, to be honest. Get best voltage. Like this. Yeah, something like this. Boom, 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 boom. Something like this. Return maxes, bing, bang, boom. This is like this. Get best joltage row, and then we can do some tests here. Get best joltage. So what are we expecting? We're like, 1, 2, 3, 4, 5, 6, 7, 8 should give us 78. What am I doing? Guys, to testing. Expect equal strings of 78 and this. I think we have to put an ampersand there. Okay, cool. Then we're like 9001 or something. I don't know if 0 is a valid character in here. Let's just assume for now it's not. I don't know if that matters, but you know. I guess this is not right. This should say 91. Cool. Let's do something like 98, like this. We should do something like, I don't know. What are like other edge cases here? Like something like this should also say 99. I guess maybe I feel like 3 digits 998 is like some sort of like shitty edge case there, which it's passing. I don't know. Anything else we should be worried about? 97, 98. Like 32, 42, 52, 63 or something. I don't know. I'm just really feeling it out. Just those feel like some sort of edge cases, but it looks like we're chilling. So I guess maybe if we're fine, we're fine. The total output voltage is the sum of the maximum voltage from each bank. Okay. So can we test this on the example now? And then go from there. Day 3 input example. Oopsies. Like this. Let's see. Where's my syntax outlining? Hello? Whatever. Example, and then we're supposed to be summing everything, right? That's what we're supposed to be doing. Total is 0. So here our maxes are in string form still, which is fine. So here we have to do like std format parse int, which we could do a little better, but that's okay. Usize this string and 0 or I guess base 10. Let him do his thing. And total plus equals try this thing, and then std debug print the total. All right. Shouldn't the last one be 63? Test case? Did I not write that? Am I stupid? I might be. I'm not sure what you're talking about. 357, which I think is the number they said. So I think we're chilling. I think we just fucking run it, dude, and just see what happens. I saw 64. Gotcha. We're fucking chilling. Gold star, baby. All right. Day 3, part 2. This part, we'll see how much harder it gets. Day 1, part 2 was fucked. Day 2, part 2 was easy. So we'll see. The escalator doesn't move because we suck ass. The elf explains that it probably needs more joltage to overcome the static friction of the system. Stiction? What is this? I'm sorry. What in the fuck is going on? Why is this its own word? I've never seen this in my life. Why isn't this just static friction? It's redirected from static friction. How confusing. Man, never heard of stiction. Sorry. Okay. The system and hits a big red joltage limit safety override button. You lose count of the number of times she needs to confirm, yes, I'm sure, and decorate the lobby a bit while you wait. Now, wait, what the fuck? So, probably needs more voltage to overcome static friction with the system, and hits the big... Oh, does the elf hit the big red voltage limit safety override button? Maybe. Or maybe the elevator hits it. Surely the elf is hitting it. You lose count of the number of times you need to confirm, yes, I'm sure, and decorate the lobby while you wait. Now, you need to make the largest voltage by turning on exactly 12 batteries within each bank. Oh, interesting. I thought it was going to be rearranged, but now it's that we get to pick 12. The voltage output for the bank is still the number formed by the digits of the batteries you turn on. The only difference is that now there'll be 12 digits in each bank voltage instead of 2. Consider again the example from before. Now the voltages are much larger. I assume the input example is the same. 9, 8, 7, 6, 5, 4, 3, 2, 1, 8, and then the ones and 9, 2, 4, 2, 3. Yeah, I think there's the same input. Okay, wait, that should be pretty easy, right? Like, we just turn this into, like, a generic version of this? Right? So, the only difference is maybe we take in, like, outbuff. And we do outbuff is equal to splat 0. I don't know if splatting works into a slight like this. We might have to do memset 0 outbuff or something. Okay, and then the trick is, basically instead of, we need to limit this by row len minus outbuff len minus 1, probably, right? Something like this, right? Because then 2 becomes 1, which is what it was before. This guy doesn't return shit anymore. I think we want to assert that the outbuff len is greater than row len. I think that our code might not work if it's the same size. I'm not really sure. Then we still probably check max is 0, but it's probably like we want to iterate every time. It's like instead of this like if else if, we want to iterate through the outbuffer. Existing or something. And then like if C is greater than existing, I think we memset the rest of the buffer. I think. Right? It's something like this. So we go like out buff from I plus 1 onwards to 0. So we need I in here. Which means that, I guess J maybe. Something like this. And then we probably break the loop here. Yeah. And is this stupid? I think this is stupid. I think that there's a chance that we're doing like way too many comparisons here, right? Because it means that like for every character, well, this ends up being like 12n or something. Right? We compare with each character. Well, probably like less than this. This is like worst case, probably, right? In the worst case, we compare each number with each character in the input with each position in the output every time. There's probably some trick here where you search backwards instead. Or like you go character by character or something. Right? Like you know if you have like 999 like 9119, maybe it doesn't matter. I feel like there's something where like you kind of know that you want I was gonna say that you want the last thing that you find, right? If you have like 12 digits remaining here, you want to look here, but that's not actually true. You actually want to you want to look at this one because you want your second digit to be this one, and your third digit to be this one, and your fourth digit to be this one. So I wonder if you do have to search forwards. Yeah, you might. I'm not sure. This might be fucking stupid. Okay. Out buff J is equal to character here. You know, something like that. And am I missing... Does anyone have the problem statement? It's basically find in a sequence of digits, the skipping however many digits you want. Pick the biggest number you can make by dropping digits, essentially. Oh, yeah, wait, there's a better answer here, right? Like, is the, I'm kind of saying, let's walk forwards and try to find the biggest thing. But the other option is, you just ditch the smallest things. Which requires a sort of the indexes, which isn't ideal. Yeah, maybe that's not faster. Right? Because what's our a typical sort? It's got to be like n log n is probably like the best you can do, right? For a sort, right? You look at each character, like log n times for like comparison. Yeah, so I think that's worse. I think sorting and then dropping the lowest characters is the worst, or is worse than just ripping the list the way we're doing it. I think. I don't know. Feels like it. Feels like it. Okay, we'll keep going with this approach then. We're missing something. It's because here we are like this condition is looking at digits like if you have like a 10-digit string and we're looking for 3 digits output, this is looking at like the first 7 characters or something. But we need to like correct the end of this. So I think it might be something like, yeah, where do we cover the like end characters? With the take the lowest out approach, you don't need to sort. You either have to sort or you have to rip the list, the whole input list. Like, if your input list is like 100 characters, don't you like, and you're trying to get 12 out, you would have to either like sort, then take top 12, or iterate 88 times and remove lowest, right? Or maybe iterate twice and find threshold. Maybe there's something like this. You iterate once to find, iterate once to find the cut threshold, then iterate a second time to remove anything below that, and then there's another problem here though, because if you have like 9, 8, 8, 8, 8, 9, and then like a bunch of 7s, and then some like 8s and 9s again, I don't really know how I'm trying to like you end up with like a threshold of 8 maybe, right? So then you like delete all the 7s here, but then you have like too many characters still, and like figuring out which ones to drop is probably confusing. So you might have to do a third pass where you delete anything that's like earliest, then delete anything at the threshold going forwards or something. You could do that. You only iterate once, count the occurrence of digits, drop the number with the fewest. I don't think that's true. You have to like preserve order. Yeah, but I mean, this is still faster than what I was gonna do. So I do like that. That's faster than what I was doing, I think. And like easier in terms of like the edge condition at the end is kind of gone. I'm down to try that. Is there a way to kind of get rid of that third iteration? One, two, three, four will always be bigger than 9988. 9988 is bigger than 1, 2, 3, 4. So I think you're confused. Maybe not. Yeah, okay. I want to try this approach. But it becomes 2 to 4 versus 9 9 or 8 8. Maybe I don't think I understand what you're saying. Okay, yeah, let's do this. Let's try this approach. So we go for threshold is 0. I don't think I understand the problem statement. The problem statement is if I have 991199 and I'm trying to extract the 4 digits in order that make the biggest base 10 number, it's 9999, right? Drop these ones to get 9999, right? If you had like maybe 8 9 like 7 8 9 3 or something here, you would probably want to drop to get the biggest 4 digit number out of here. You drop the 7, the 8, and the 1s to get 9399. You know what I mean? You're like you have to preserve order, and you can just delete things from the list to get to like, you have to get to like a 12 digit number though in the scenario. Okay. You have a fixed output? Yeah, fixed length. Yeah. Okay, yeah, I think I like the approach of scanning the list 3 times. Search the list, start with the right 12 digits, search backwards until you find our first digit. Yeah, but then you have to do, you still have the trick where you have to iterate multiple times, right, for each digit that you're going through, which was what I was trying to avoid. I think I like my approach. I think we'll see. Okay, so for row, this is a simple classic double pointer. Am I stupid? If you have like 12 digits of output, I feel like 2 pointers isn't enough. Right? Like, you have to do double pointer once per pair of characters, I think. Right? Because you like scan forward until you find, if you find like, you're looking for, you know, something here. So you find the first character, and then you like you move your second pointer forwards, boop, 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 until you find another character, next pointer forward. Maybe I'm not understanding what you're doing with the 2 pointers. But if you're trying to find like 12 characters, I feel like 2 isn't enough. But maybe I'm missing something. I'm gonna do my approach. I'm gonna do it. Fuck it. Okay. For row. How do I find the threshold? Maybe I'm wrong. Maybe it's not simple. I guess you count each character. Which makes me think, the more I think about this, the more I'm starting to think that this is more expensive than my initial thought. My initial thought was that this would be cheap because you just find the threshold and that's like 1 iteration, then you delete the threshold. But now I'm thinking that since you need to like figure out what that threshold is, I think that might not be as cheap as just like a scan once. So I'm going back to my other answer. The other answer of iterate the list, find if the character is bigger than existing. I don't think you can scan once. Yeah, I don't think so either. I've changed my mind. Okay, so what are we doing? We iterate. I do think that you guys had something when you were saying start with the last 12 digits. That's probably the key, right? So we have like stuff over here. We start with this as our output, you know? And then we scan forwards until we find something better for the first character. So then we pick this one. Then we keep going, and if we find a character that's bigger than the second character now, we like move that over. Okay. Then we might find something here that's better than the first character again. So I think that we reset the second character to this position. And set the first character to this. And then every character from the input stream we compare with all 12 characters in the output. Yeah, that seems pretty reasonable. And then I think that if we just keep doing that, when we get to the where we keep, instead of mem setting to 0, we mem copy in this buffer, then I think we're probably fine. I think that that'll do the right thing. So instead of a mem set here, we're gonna do a mem copy of row row len minus outbuff len onwards or something. And this here, we are mem setting everything after J, the second, like the inner loop here. So plus J here. And then outpuff from J onwards. Plus 1, maybe? Yeah, something like that. Something like that. Then I think that we don't need this cleanup case at the end. That feels kind of right. Okay, so now let's start by seeing how much we fucked up the existing case, right? So we need to reset these tests a little bit. So the test, each of these guys, to convert this into the new format, we say outbuff is 2 U8s. And for each of these guys, it's like, go to the ampersand, delete till this, paste it here, oopsies, and then put outbuff here, and then put outbuff here. Oopsies, okay, not quite. Let's try that again. Jump a couple words, move forward by character, select till here, paste it, put in outbuff, put in outbuff. There we go, that feels about right. So I think that if I did this right, everything here should still work. And if it didn't, then we could fix it on 2 and then try on 12 after. Yeah, I guess someone is mad here, huh? Mem set, oh yeah, mem copy, not mem set. Boom, boom, ba-dum, ba-dum, ba-dum. Okay. Yeah, this is wrong. Other way on the assertion. Okay, so here he's mad because 63 failed here. So all of these worked. This one didn't, which means our edge case at the end is probably fucking wrong. Instead found 66. Means that this mem copy is probably wrong. This mem copy is probably wrong. But the lengths are correct, which is interesting. So he's getting to like, maybe this -1 might be wrong. I'm actually like very unsure here about what is incorrect here. So we're going from row len, this is going to be like, in this case, 1, 2, 3, 4, 5, 6, 7, 8. 8 minus 2 minus 1. Oh, right. So this is going to turn into 8 minus 1, which is 7. I just finished loop. I don't think you can. Am I crazy? I don't think you can, because you then have to compare, you have to like limit which characters in the output you're comparing with that way, which is like maybe fine. Yeah, you could do it the other way, right? You could do it like row len here, and then here do like some sort of like max trick here, but I don't think I want to do it that way. Seems like you have to limit the mem copy range based on I. No, I don't think, because I is always, we're limiting it so that we're always mem copying the last 11 bytes. in a 12 byte buffer, or the last 1 byte. It should be. Let's just double check that. So here we're ripping the output buffer. I feel like it might be this, though. Because we're always resetting the first character here. Are we? No. No. Here we're checking each character in the output buffer. And we're saying if this character is bigger, then set this character to the thing we found, and then reset all of the last characters in the buffer. That's what's supposed to be happening. Something about this feels stupid, though. I'm not quite seeing it. But it feels like... Okay, so I have like 1, 2, 3, 4. And I'm looking at 3, and I'm comparing 3 with every character in my output buffer. So maybe right now... Or let's do it the other way, sorry. So 4, 3, 2, 1. So we start with an array here. Right? This is our output. And then we find 4. Right? So we go 4, chill. So now our output buffer is 4, 1 because we like replace the 2. Then we break at that point. We reset and break. Cool. So then we look at 3. And we go 3 is not less than 4, or 3 is less than 4, so we don't take this one. But it is bigger than 1. So then we set second digit to 3. Which is fine. I don't know why we're talking about this. Okay, so maybe we do. Let's try something else. 4, 3, 4, 5, 2, 1. Maybe is the way to look at this now. So we look at 4. 4 is bigger than 2, so we replace 2 in the output buffer. Reset 1. Then we look at 5. 5 is bigger than 4. Also not very helpful. Also not very helpful because then we just do the same thing. Everyone's happy. The question is why is this... Okay, if we throw some 1s at the end of this, does that fix the test? Yes. Okay, so that's interesting, right? It's specifically when we're at the end of the buffer. So I think that we just want to do this. Replacing this with this. Can we do that? Let's just do this for a second. Maybe I forgot a new line? Oh, that's weird. That's very strange, because we're seeing, like, replacing blank with blank. Hello? Hello? That feels like memory corruption, no? Because this should all be valid characters all the time, I would think. Like, what the fuck? Oh, the length of the array is 0. That's interesting. So we're looking at, like, the last character here, maybe, or something? Probably something like that. Which is fine. Okay, so that actually is okay. Let's just put the links in here so I don't get lost. Dest, can we also do this? Dest is, oopsies. Source is this guy. Oopsies. Oopies. Okay. So now we can do dest len, source len, and then we can do a mem copy of dest to source. Easy peasy. No lean. Yeah, okay. So that's fine. Why do we not see any logs related to this 6 though? Right? Am I stupid now? Like, Replacing length 0 with length 0. I mean, that's the problem, right? Oh! Okay, wait. So why I would think this should just work as is. It's probably this I'm missing something? No, because I'm copying fully into outbuff. Initial output. Like, this should already start at 63, right? Yeah, it does. And then we're like somehow fucking it up into 66. Right? So what am I missing there? Because we're also, according to this, doing no mem copies anywhere? It must be that here, replacing it must be that he's like looking at the 6 and replacing the second character with it. Oh, because if the first character, it's not less than. Here he's doing like 6. He's like 6 is not greater than the existing 6. So let me try applying that 6 to the second digit, which isn't allowed here. So yeah, I think that we need to limit this somehow. But also we should never get to the 6. So maybe the bug is this -1. Wow, even more confusing. Now it says 65. That's so much more confusing. Hello? Oh! Because the initial value of this is the 63, right? But the first character is like never reset. Right? So he's like iterating through this and he's going bing, bang, bing, bing, bing. He sees the 5 and he's like, oh, fuck me. Like, 5 is not bigger than 6, but 5 sure is bigger than 3, which is the character at the end, because he doesn't realize that, like, he can only be. If it's less, we have to break out early. Somehow. Yeah, I'm doing something stupid here. So what is happening? We're looking at, like, every character for every character. Okay, so I'm looking at like 63, right? And I see I'm looking at a 5 over here. And it's like invalid for me to compare this 5 with this 3 because he is smaller than the because what? Why is that true? Because the 6 is not to the left of him. Yeah. Oopies. So that's fucking stupid. I wonder if it's something like we have to search backwards and then forwards and then backwards and then forwards or something. Yeah. There's something there. Something there. Okay. Okay. So back our initial solution, which wasn't just like pre-initializing the last characters, was we were setting the initial buffer to 0s and then walking forwards through the list of characters, and that's why like the previous approach was valid, right? Because like we knew that like everything would always be greater than these guys. Like we seeded the state correctly. And now we're not doing that. Can we keep doing that with many characters? Maybe, maybe not. Okay. Thinking again. Thinking again. So, I mean, the first character is obvious, right? We start with the first character. The first character, you iterate by input, and if it's bigger, it's bigger. There's the recursion strategy, which I've been trying to avoid, where you kind of say, okay, now we continue on with the next character. And do the same thing, but with like the input scoped from where we started at. And maybe you do just have to do that? Like, is that the real answer here? That you literally just have to do the scan, like, you have to do this, like, 12-pointer bullshit? I would hate for that to be the answer. It feels like there must be something more elegant, which is what I've been looking for. But maybe you do just need to store all 12 pointers. It just feels wrong. Okay. So there's also something where okay, so I've been trying to kind of feed one character at a time to the buffer. Does that work? Can that work? So we kind of have this like output buffer who's seeded with zeros. We feed him 6. We check here. We say, great, 6. Continue on. Then we feed him 3. And we go, no, yes, chill. So this becomes 3. 6, 3. Then we feed him 3. And we go, no, 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 3. Everyone's happy, right? Then I feed him 4. And I think here, the problem is with this statement of the problem, he goes here and he goes, this has to go 4. And so all of these guys get zeroed out again. But he doesn't know if this is valid. He doesn't know if there's like enough characters past this to fill the rest of the buffer. So I think we're very close with this idea. But we just need a limit as well on how many are remaining. Yeah. So if we push 4 plus remaining characters, then this becomes simple. Okay, yeah. And then in my head, the way that this is turning out is it makes sense to me in my brain to do like outbuff. Okay. And this guy's like literally just like push like this. Maybe it's like this. Character and remaining length, or like len. Yeah, remaining. Then this is like 4 out self buff I'm not sure yet. It's just this is how it's making sense to me. Okay. Thinking. So then we say, we do the same thing. If C is greater than existing, you know. So we're missing a piece here though. We need to do like if remaining is less than I break, I think we have to give up. Or it's like self buff relevant buff maybe is like something like this. Yeah. Like compare start is something like the minimum, maximum of something. Maybe I'm not sure. Something to do with like buff len minus remaining. So if the remaining is really big, we look at 0. But if remaining is really small, like remaining is 1 byte, we want to look at buff len minus 1. So this is gonna be the maximum, I think. Or is it just like this? Is it literally just like this? So if buff length is 2, if remaining is really large, anything bigger than 2, we will start there. Yes. But then if remaining is only 1, then we will only start looking at this from... there's a -1 in here somewhere. Okay, so if buff len is 2 and remaining is 2, we want to look at 0, which is great. If remaining is 1, we want to start from 1, which this will happen. If remaining is 0, remaining can't be 0, because otherwise this character wouldn't have come in. Okay, that seems right. And then what is this I for? He's for replacing the end. So like, which we are not doing anymore. So we are just doing a mem set now on the case where compare buff. Let's do this. Okay, this is starting to look right. This is starting to look right. Yeah. This feels right. Yeah. And then if there's like some break case here where I think we just like return here. Break maybe? It's kind of equivalent in this scenario. Yep, okay. Let's try that. Let's try that. So now we have out buff here. Like, I don't know, sync or something. And let's initialize this to zeros for now. And then we do like for row CI, we like shove shit into the sync, right? It's just like sync, push, C, and row len minus I. That feels right. That feels right. Okay, so that kind of fixed this test. Do the other tests still work with a buff length of 2? Oh, big win for us. Okay, so now with buff length 2, this is all still working. And we should be able to, like, buff 2. We should be able to start, like, incrementing this now, right? So, like, buff 4, right? We'll do all the same tests, but now this is 5, 6, 7, 8. This is not 1, 1, 1. This is 9, 1, 1, 8. This guy is not valid, so we'll just throw 9, 8, 7, 6 or something. Did I hear 6, 7? Yeah, great. And now this is 5, 2, 6, 3. That's really promising. That's pretty promising that this works. We're probably missing some edge cases in our tests, but not enough for me to care. So let's try the example input now. With this new thing. Now we just need to change this though, where we have our out buff. Is, what is it? It's 12. And we are trying to do get best joltage of the row with this 12 byte buffer. And then here we should be able to do out buff here. And can we try it on the input now? or the test input. So he said we should get 3121910778619. So we do get the right answer here. So we could try this on the full input now, and instead of like thinking, just fucking run it and see if we get the right answer. Let's fucking go, baby! So this solution is not, I assume it's not ideal. I assume. But I don't know, like, I can't quite piece together where it's missing, right? Like, what are we even doing here? It's every input in the stream we are comparing with every character in the output until it's bigger than 1. So this is like MN, right? And it seems like you could do I feel like you could do something better. I just don't know if I could be wrong there. Right? Like you kind of have some constraint on the output where for a good chunk of it, you know that the numbers on the left have to be greater than or equal to the numbers on the right, except for the last 12 digits or the last 11 digits. In that case, that's no longer true. But everything before that, that's true. And you could probably leverage that information in some way. And I just don't know what that is. So if this was the only thing we were doing today, I would try to think about it harder and try to optimize it. But because we have to do day 4 as well, I'm kind of down to cheat. Two-Step is linking this solution. He says, I really like this one. Let's see. So what are they doing? OMN or OM log MN. Yeah, I feel that's kind of how I'm feeling. You know what I'm saying? So what's this guy doing? Joltage. 0 to n, where n is the length of the buffer, where, right, so his n may be 12 here, right? That's what he's doing here for part 2. He is saying he's doing an append on the array if, just in general? How is that possible? Oh, sure. So he's scanning forwards in the array every time from where he is. Oh, yeah, that is kind of clever. So he's going for each character. Oh, no, wait, hold on. I'm missing something here. For each character, he's storing... Oh, yeah. Okay, so he's starting by finding the... He's iterating every character to find the biggest one in the first chunk less than 12 bytes. Yeah. So he's doing something where he's going like, I know that, so in my input buffer of this length, I know that the first n character, like the first character has to be in here. And then he's saying iterate forwards until you find the first thing that is big. Find the biggest thing in here the first time. Right? So index of max here, what is this doing? This has to be looking at the whole... This has to look at the whole input string, right? Hello, clicky. Here we go. Okay, whatever. Oh, I see. That's why. Okay, so this guy has to look over... Yeah, he's looking over the whole slice. So his solution is like n minus m plus n minus m minus 1 plus n minus m minus 2, I think. No, it's not quite like that. But so on the first character, he's searching all of this. Then on the second character, he's searching kind of like all of this. And then on the third character, he's searching like this, right? They're kind of like making it so that for each character, you expand the search on the right side a little bit. Which makes me think that this solution I don't think is super efficient. Is it better or worse than mine? It's got to be better, right? Because he's scoping the search for each character, where I'm kind of looking at every character in the output for every character in the input. I think. I guess mine, the duplication's in the output buffer. And on this one, the duplication's on like the input buffer, which is bigger. So I'm not sure. There's probably something to do. There's probably something there. Let's look at Greyhatter solution. What did he do? So did you check if this works, Greyhatter, by the way? Because like I'm not, me looking at this if it didn't work is maybe stupid. Input len minus outbuff len. Okay. You're going for each of these things. What the fuck am I looking at? For outbuff input, we're just assigning. This is like a memcopy. Sure, this is a memcopy. This guy is setting the input to go for the first, like, you know, drop the last 12 bytes of this thing for each input here. This is double looping here for each input in, for each outbuff in out. If this is bigger, you just set it and then continue. Oh, interesting. Yeah, you're using continue here as your way to cheat your way out. Interesting. Yeah, okay. None of these solutions so far make me think my version's that stupid. What's going on here? This is from Genociet. What is happening here? This is C, right? Of course. Sorry, my brain. We're going for each character M to N, where N is probably like 12 here. Yeah, so N is 12 in this scenario. We're going for 0 to 12. We're limiting the thing by the right side of that thing, right? So that means that you must be looking for the smallest character first, right? I think. Yeah, because this is, no, 12 minus 0 minus 1. So this is the first character first. And then we're doing for inner loop, same thing. No break here, though. No break, and then like a fix up at the end, I guess? No, what's this? This is just, oh, this is conversion to actual character. So here, I think this is like similar again in terms of like complexity. So this is going character by character. Yeah, I see. So this is the same as like the initial solution that Two Step sent, where the doubling up is on the related to the length of the input line, not the output line. All right, interesting. Okay, I'm gonna stop clicking on people's solutions. It doesn't look like, at the very least, from what you guys have sent me, it doesn't look like there's some like really, really big trick that I've missed. However, I think that there's a good chance that I've miscalculated the cost of like duplicating on output buffer length versus input buffer length. You know what I mean? It's very likely that I've mistaken that. But whatever. Fuck it. Day 4, baby. Day 4, part 1. When are you doing window manager continuation? We've been hacking away at it a little bit in happy hour. But it's likely that like mainstream VODs won't pick back up on it until Advent of Code ends, because I'm having fun doing this. But like, it's possible that I will get bored of Advent of Code and then we'll go back. You never know. You never know. I ignored your 6-7 joke last time, but you're posting it again, so maybe I'll say it. I assume you know why 6 is afraid of 7, but do you know why 10 is always scared too? 6, 7, because 7, 8, 9. 10 is scared because 7, 8, 9. Okay. Printing department. You ride the escalator down. So, right, we fixed the elevator. We fixed the escalator. Go us. Fuck yeah. You ride the escalator down to the printing department. They're clearly getting ready for Christmas. They have lots of rolls of paper everywhere, and there's even... Okay, because 10 is... Okay, I'm not... That's crazy. Okay, you ride the escalator down to the printing department. They're clearly getting ready for Christmas. They have lots of large rolls of paper everywhere. And there's even a massive printer in the corner to handle really big print jobs. Decorating here will be easy. They can make their own decorations. What you really need is a way to get further into the North Pole, right? Because, like, well, I don't give a fuck about the decorations. I need to get fucking working, man. Actually, maybe we can up with that, they say. We're pretty sure there's a cafeteria on the other side of the back wall. If you could break through the wall, you'd be able to keep moving. I like the idea of, like, you're like, I gotta get to work, man. I gotta get to work. And they're like, just fucking punch a hole through the wall. And I'm like, okay. If we could break the wall, you'd be able to keep moving. It's too bad all of our forklifts are so busy moving these big rolls of paper around. If you can optimize the work the forklifts are doing, maybe we would have time to spare to break through the wall. The rolls of paper, at signs, are arranged on a large grid. The elves even have a helpful diagram indicating where everything is located. For example, this shit. The forklifts can only access a roll of paper if there are fewer than 4 rolls of paper in the 8 adjacent positions. Okay, if you can figure out which rolls of paper the forklifts can access, they'll spend less time looking and more time breaking down the wall at the cafeteria. So here, we're literally just counting. Wait, what are the X's? That can be there are 13 rolls of paper that can be accessed. The X's are the rolls that can be accessed, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Oh, sure, because edge ones can be edges are not like there aren't walls around this thing. Sure. They're like in the center of a room. Right. So they're not talking about like routing of the forklift or anything. They're literally just like count around you. Right? So this is just like an image kernel, right? You just rip you zero pad the output, you rip your image kernel over, and this could be you could do this like on GPU, like we did for all of our like neural network things that we were working on, right? You could basically one-shot this on GPU, which is very funny. And when we do, and I think we can maybe make an assumption. We can make an assumption that is like one of the fastest things that we could do, because like neural network image stuff, they use image kernels where you just slide over the whole input. So it's like, if that was like really fucking slow and there was something smarter, then they wouldn't really do that. So let's just do like the equivalent on CPU, I guess, because I'm not gonna do the GPU version. Okay. So, in the past when we've done this, we've had great success with the idea of like an image pixel iterator, I think. Right, where you have some like, input buff. And you want to be able to like iterate kind of like an area around that pixel. So maybe this is like a kernel iter. And this guy will handle the idea that like if you're out of bounds, then he needs to return a specific thing, right? So we're gonna look at like our x probably, and this has to be integer because we could go out of bounds of the array, right? If we're starting at like -1, -1, this is like relative position to our center. Unclear so far. Center position has to be on screen, so we can probably get away with like unsigned. And when we, and it's like basically our like next function here is going to return probably just the pixel value. And we're gonna look at like self x plus self cx. And we're gonna look, I guess we need to like figure out like the width of this thing. We can kind of hard code that. Right, I think. 8 adjacent positions, yeah. I guess technically we don't have to compare with ourselves, which is nice. Yeah, so it's like if self x is, well, we've also had success doing it this way as well, where we have like inc x or step x, because sometimes we've wanted to like do y and x iteration independently, but here I guess we're probably okay with doing it all at once. So if I guess like self y, maybe we do this. Maybe. No, it's fine. If self y is greater than 1, or greater than or equal to 1, greater than 1, probably. Return null, we're donezo. So these are gonna be like, we're gonna have x and y expected to be like -1 to 1, something like that. Else if self x is greater than 1, we need to reset, so self x is equal to -1, and self y plus equals 1, and we continue probably, so we put this in the loop. And so now we have our x and y positions. We're also going to do like if self y is equal to 0 and self x equals 0. Continue probably because we don't have to check the center position. How does U31 work in SIG? Basically just use 32 bits but not allowed to be negative? Yeah, it can pack them if you ask it to, but I just do that because it makes it easy to work with I32s and U31s, because an I32 can represent every value in a U31, so that like you don't have to do like casting. But yeah, you can think of it like a U32 that's limited in length. Okay, so now we've kind of covered all these cases, so we just have self cx. I guess we're looking at like, do we need width in here? Probably, right? So we're probably looking at like val, and then val is like what, like, I guess we should call these offs, huh? That's clearer. That's clear. Okay. I guess we're not using this kernel width thing right now, by the way. Are we missing some increments? I feel like we are, right? Probably something like this. Probably something like this. I guess this is silly, right? Because like usually what we would normally do is you would store like an index, and then you would like calculate the x and y offset from that. Is easier in some ways. But I've already written this, so it's fine. It's fine. Okay, so this is like width times, it's like y is self y offs plus cy, x is x offset plus cx. And then can we do something like if x is less than 0, crash. If y is less than 0, crash. I guess we'll do it like this. That x is greater than or equal to 0. Same with y. Okay. And then we're like, I guess it's easier to do this. We'll do a cast here. Or else unreachable. There we go. No, this isn't true, right? Because if x is less than 0, if x is less than 0 or y is less than 0, this is like a valid thing to happen. We just return like what is the puzzle look like? Dots, right? So we return a dot here to indicate that there would be empty space there. And then also or x is greater than width, or y is greater than buff len over self width or something. All of these cases are like we're out of bounds and we return the dot. And then here we return this guy. So this is times x times y plus x. There we go. And then this should be valid. There we go. Got there eventually. Okay. So now we just have to like parse this stuff, right? So what does our puzzle look like? We have dots and ats online. So I guess we say input or f is stud fs current working directory open file of day 4 input. We are going to do I guess we do like read the first row. I guess we will do some dynamic allocation, maybe. Maybe not. We might be able to do it without it. So let's do reader as usual is, you know, a buffer of u8s. And we need to make sure that this is at least as long, needs to be at least as long as one line, I think. Or else we can't do like take, hold on. This is reader buff, not reader. So if we're trying to do something that's like, hold on. If we're trying to do like reader take delimiter exclusive like this has to how do I say this? This has to buffer at least one line. We could just like represent this though directly in memory. We could just do this. Content buff is, I don't know. Surely it's not bigger than a meg, and we have plenty of stack space for that. So we should be able to be like, f read all into content buff, and we don't have to do any like fancy reader shit. And then this, we just have to make sure that when we do width here, this is there's somewhere where we need to do a -1. I think it's here. Because now there's like new lines kind of like sitting around in our output or in our buffer that we're just trying to like fucking ignore. So I think we can get away with this. So I think we can read into this buffer just like this. And then we can say width is index of scalar in the content buffer of the new line. Or else unreachable, we crash. And then we subtract 1 probably. No, we just leave it. Yeah. So then we make our little kernel buff is content buff. Our width is width. Our cx I guess we do this for each character. So for 0 to height, y, and then we go for 0 to width -1 of x, because there's the new line in there that we have to dodge. For each character, we make our kernel iterator, where we set our x offset to -1 and y offset to -1. Cx is x and cy is y. This should do what we want. Okay, so we have our iterator here, and then we go for like while iter next. We say what? We're like, I guess for now, can we render the expected output? I think that's like the easiest way to like to verify that this is right? So after every row, we print a new line. For each character here, it's like I guess we have the count here. And it's like count plus equals C. I guess it's like if C is equal to dot. This is like the free space, right? Then we're kind of chilling. And here it's like if count is greater than or equal to, was it 4? Yeah. We print an X. Right? Otherwise, we print a add to match their diagram. And then I think we should kind of just be like, we're good to go. If we copy paste this example input somewhere. Day for input example. Okay, let's see. Oh, I guess we do need to do this, huh? Yeah. Something like that. Width, he is pissed. Uh-huh. Something like this. Maybe like this. I like using wrapping math to simplify the bounds of the grid checking in these problems. But it isn't like that only works if it's a power of 2, right? I thought, which it might be. I didn't check that. What is it fucking bitching about down here? Yeah, I guess this is true. So here we have XU. At this point, this is fair. So we use the unsigned versions here after we've checked everything. Print line of a new line needs a little one of these guys. You can do X minus equals, and then you have to check X is less than W. Ah, I see. I see. We're missing something, huh? We're only checking, we only want to do this if character center val is the content at width times x plus times y plus x. if center val is equal to an at sign, then we do all this. Otherwise, we print a dot. Oopies. Okay, does that look like what they wrote? Dot dot xx dot xx. Ooh, not this one. Why not? 1, 2, 3, 4. Is it the boundary condition? Greater than 4. Okay, does this look more like what they wrote? No. Okay, then I'm missing something. Either we're doing this wrong or we're confused. So this guy right here, you should count paper rolls now. I thought they were the same. I thought they were the same, but maybe it's not. So here we should be seeing 1, 2, 3, 4 empty spaces. Okay, what about here? 1, 2, 3, 4, 5 empty spaces. Wait, so it should be greater than 4. Should be fine. So why is this guy no longer triggering? Wait, isn't this wrong? Hold on, let's, can we print the puzzle input? Can we print the puzzle input? No, this is right. We did copy paste this correctly. So, okay. What are we doing wrong? I mean, we're clearly doing something stupid because here we're printing an at, which shouldn't fucking happen. Right? That should never happen. 1, 2, 3, 4. Right? 1, 2, 3, 4. That should be a dot. So how is that ever showing up as anything? Yeah, can we just print, let's skip all this for a second. Can we literally just, can we just do print? Am I parsing the puzzle correctly? We might not be. That wouldn't shock me. Why are there extra new lines in here? That's probably related. What the fuck is going on? Yeah, I mean, okay. Clearly I'm doing something stupid with parsing the puzzle. It looks like we are including the new lines when we're parsing, which is bad. Which is bad. So, -1 here. Am I stupid? Width is the index of this. Std debug print. Width is this. I must be doing something stupid. I just can't find it. Width 10. So is that correct? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Great. Great. So, oh. This needs to be +1. This needs to be +1 for the lengths to work out, and then this needs to be -1 here. Because we are the new line needs to be included in the width. I forgot. Okay, there we go. So now new lines are not in here. Draw the new line again. There we go. There we go. And now can we go back to printing our interpretation of this puzzle? Does that look more correct? XX, 2 X's, and then an at an X, X at, a bunch of ats, and then an X in the middle here, all ats, an X on each edge, ats, X on the left, ats, X, X. Yeah, okay. So it looks like we're probably doing this correctly now. Took a while, because we're fucking slow and dumb, stupid dumb. But let's see. So there should be 13. So now let's also just kind of throw the count in here. So, var total, I guess like total, like accessible roles. Like this. Okay. And then at the end of this many accessible roles. There's a good chance that I wrote role R-O-L-E at some point, and if I did that, it's because I think phonetically. Fuck you, you can't stop me. 13, cool. Condoriano, thank you for the prime. Okay, get my puzzle input, save that shit. Day 4 input. All right. So let's slap that thing in here. And can we just quickly make sure that that looks like a reasonable grid? It does look like a reasonable grid to me, which implies that we parsed the puzzle correctly. So let's just huck this 1560 at it and just see what fucking happened. Okay, shut the fuck up. We got it right though. So let's do part 2. Part 2. All right. Now the elves just need help accessing as much of the paper as they can. Once a roll of paper can be accessed from a forklift, it can be removed. Once a roll of paper is removed, the forklifts may be able to access more rolls of paper, which might also be able to remove. How many total rolls of paper could the elves remove if they keep repeating this process? Starting with the same example as above, here's the only way you could remove as many rolls. Here's one way you could remove as many rolls of paper as possible. Using highlighted ats to indicate that a roll of paper is about to be removed, and using X to indicate the roll of paper was just removed. You just rip it until you run out, right? So we just fucking edit the buffer. Right? We just edit the buffer, which means like, I think part 2 here is like almost free. I think. So this is like, while true. Okay, actually, hold on. Git add day, git status. Are we in a repo? Git init, git add day 4. Just because I think there's a good chance I'm about to fuck this up. Okay. So we can we just edit it on the fly? Probably not, right? You probably need to double buffer because whether or not a roll is accessible depends on the rolls around it. And I'm not 100% sure. I guess if you remove a roll, then it's fine. Like if you remove a roll too early, it doesn't matter. So I think you don't even need to double buffer. I think you just replace it as you go. I think that's fine. So I think all we do is we do like while true here. While true, we do whatever the fuck we were doing, and instead of printing when we print the X, can we kind of say center val is the thing here, and then we can just say center val here is equal to dot, right? Just like fucking replace that shit. And then I guess we print dot here too. Maybe we print X to indicate that we just removed it. And then here the exit condition is like removed rolls, something like this. And then it's like if removed rolls equals 0, break. Probably, right? What's he pissed about? Oh, we don't. Well, right. So here it's like removed roles plus equals 1. And then here, when we're using center val now, we do have to dereference, huh? Okay, cool. And then can we do this on the example input? Okay, so that seems good. So the question is do we get to the same end state? That looks right to me, right? It looks like we're getting to the same end state. So what is the number that we're trying to calculate here? 43 rolls of paper. Oh, we're already happening to calculate the right thing. That's pretty funny. That's pretty funny. Okay, so all we have to do now is just not do this like line by line print because this is gonna like fucking murder us. Okay. And then can we just run it on the actual output? All right, what do you guys think the chances are that this is right? Let's go! Easy peasy. Easy. All right. Well, that was pleasant. And what's kind of nice here is, like, this one, it would be a fun one to optimize if I felt like it, right? Because you could easily GPU accelerate this one, right? Which is really fun, right? Because if you just double buffer, like what we've done is we've kind of said as we remove rolls, we immediately see that effect on the next roll check. But you don't have to do that, right? You could do it in like stages, right? And if you do it in stages where you go, let me check all the things I can remove in this iteration, then check all the things I can remove in the next iteration after we remove those, you could go on GPU and you could like double buffer. And then this is just like this is just like an image processing problem, which we've done lots of. So do it in OpenCL. Yeah, I think that would be the thing to do. I don't want to right now. I don't think it's worth it, especially because we've done so much like of this type of work before on the barcode scanner project, right? Just like so much like in an OpenCL kernel, iterate these things and apply this kernel and then like check for these things. Like we've done all this before, so it's not really like an interesting problem to me. But it is exciting that like these problems that we've done before like just immediately jump us into the right solution here, which is kind of funny. All right. Well, I wasn't sure when I started stream today if each problem was going to take us 2 hours or 1 hour. So we're going to end stream super early today because I didn't consider the fact that I needed backup plan for what to work on if we finished all this so like too fast. So I'm going to call it for today. No happy hour segment. Happy Thursday, everybody. Thanks for watching. If you like what you saw, we stream most days 12:30 to 4 Pacific time. It's 2 now. Oops. But you know, we're working on Advent of Code right now, but there's also other stuff that we usually work on. So tomorrow we'll probably do a segment where we work on our dbus library and then do Advent of Code day 5 in the second half. But yeah, if you want to see the other stuff, follow the YouTube, keep up, you know, swing back by on Twitch, whatever. Sometimes the other segment goes up on Patreon or YouTube members or in paid Twitch VODs. It just basically depends on like what we worked on the day that makes like the best story for a YouTube title and thumbnail. That goes on like the main YouTube channel, and then everything else gets put on Patreon and friends. Cool. Thanks for watching. YouTube, peace out, and Twitch, let's find someone to raid.